Hi guys. So we are back with another live stream, and today we are going to talk about the pathology, reversible and irreversible cell injury, and the apoptosis and the necrosis differences between them. So let's begin. So, morphology of the reversible cell injury. The term degeneration has been used to denote morphology of the reversible cell injury. Following morphology forms of a reversible cell injury are included under this heading. Hydropic changes, cloudy swelling or vacuolar degeneration, fatty change and hyaline change and mucoid change. So hydropic change means accumulation of water within the cytoplasm of the cell. Other synonyms used are cloudy swelling for gross appearance of the affected organ and vacuolar degeneration. Okay. Etiology, this is the commonest and earliest form of a cell injury from almost all causes. Etiological agents are bacterial toxins, chemicals, poisons, burns, high fever, intravenous administration of hypertonic glucose, saline, etc. Pathogenesis. So, cloudy swelling result from impaired regulation of sodium and potassium at the level of the cell membrane. This results in intracellular accumulation of sodium and escape of potassium. This leads to rapid flow of water into the cell to maintain isosmotic conditions. Cellular swelling occurs. In addition, influx of calcium too occurs. Okay. Hydropic swelling is an entirely reversible change upon removal of an injurious agent. So, morphology features. So, grossly the affected organ like kidney, liver, pancreas, or heart muscle is enlarged due to swelling. Microscopically, it is characterized by the following features: the cells are swollen and the microvasculature compressed. Small clear vacuoles are seen in the cells and hence the term vacuolar degeneration. These vacuoles represent distinct cisternae of the endoplasmic reticulum. Some cytoplasmic blebs may be seen, thus the nucleus may appear pale. Water moves into the cytosol and the cytocavitary system and hydropic degeneration. Hyaline change. So the word hyaline means glassy. Hylos means glass in Latin. So hyaline is a descriptive histologic term for glassy homogeneous. Okay. Hyaline change is associated with heterogeneous pathologic conditions. It may be intracellular or extracellular. Intracellular accumulation. Intracellular accumulation of substances in abnormal amounts can occur within the cytoplasm, especially lysosomes or nucleus of the cells. This phenomenon was previously referred to as infiltration, implying thereby that something unusual has infiltrated the cell from outside, which is not always the case. Okay, so infiltration is the wrong way to describe the intracellular accumulation. Intracellular accumulation of the substance in mild degrees cause reversible cell injury, while more severe damage results in irreversible cell injury. So, abnormal intracellular accumulation can be divided into three groups: the accumulation of constituents of normal cell metabolism produced in excess, accumulation of lipids, fatty chains, cholesterol deposits, protein, and carbohydrates. Accumulation of abnormal substances produced as a result of abnormal metabolism due to lack of some enzymes, storage diseases, or inborn errors of metabolism. Accumulation of pigments, endogenous pigments under special circumstances, and exogenous pigment due to lack of enzymatic mechanisms. to degrade the substances or transport them to other sites. Fatty changes steatosis. So, fatty change accumulation of fat within parenchymal cells. It is especially common in liver, but may occur in other non-fatty tissues like heart, skeletal muscle, kidneys, and other organs. You know, guys, the liver and heart and kidney, these are very important organs, which do a very good job in metabolism of fats. Etiology of fatty change. Cause of fatty change in liver, conditions with excess fat, hyperlipidemia, exceeding the capacity of the liver to metabolize it. Obesity, diabetes mellitus, congenital hyperlipidemia. Okay. Liver damage, liver cell damage, alcoholic liver damage most common, starvation, protein calorie malnutrition, chronic illness, example tuberculosis, acute fatty liver in late pregnancy, hypoxia, example anemia, cardiac failure, hepatotoxins, example carbon tetrachloride, chloroform, ether, aflatoxins, and other poisons, drug-induced liver cell injury, example, administration of a methotrexate steroids. Grossly, the liver in fatty chain is enlarged with a dense glistening capsule and rounded margins. Okay, so the sorry, the cut surface bulges slightly and is pale yellow to yellow and is greasy to a touch. Microscopically, characteristics feature is the presence of numerous lipid vacuoles in the cytoplasm of the hepatocytes. The vacuoles are initially small and are present around the nucleus microvesicular. But with progression of the process, the vacuoles become larger, pushing the nucleus to the periphery of the cell, macrovesicular. At times, the hepatocytes laden with large lipid vacuoles may rupture and lipid vacuoles coalesce to form fatty cysts. At times, the hepatocyte laden with large lipid vacuoles may rupture and lipid vacuoles coalesce to form fatty cysts. Mm. So the appearance of liver is enlarged with a dense, glistening capsule and rounded margins. Microscopically, characteristic feature is the presence of a numerous lipid vacuoles in the cytoplasm of hepatocytes. The vacuoles are initially small and are present around the nucleus, microvesicular. But with but with the progression of the process, the vacuoles become larger, pushing the nucleus to the periphery of cells, macrovesicular. At times, the hepatocyte laden with large lipid vacuoles may rupture and lipid. Cholesterol deposits, intracellular deposits of cholesterol and its esters in macrophages may occur when there is a hypercholesterol cholesterol like more cholesterol in the body. So the condition occurs most often in patients with obesity. The two commonly affected organs are the heart and the pancreas. Thus, heart can be site of the intramyocardial fatty change. Pathologic accumulation of proteins in the cytoplasm of cells may occur in the following conditions. In proteinuria, there is excessive renal tubular reabsorption of protein by proximal tubular epithelial cells. In in the alpha-1 antitrypsin deficiency, the cytoplasm of the hepatocyte shows eosinophilic globular deposits of a mutant protein. Mutant. Intracellular accumulation of glycogen. Conditions associated with excessive accumulation of intracellular glycogen are as under. In diabetes mellitus, there is a intras in diabetes mellitus there is intracellular accumulation of glycogen in different tissues because normal cellular uptake of glucose is impaired. Glycogen deposits in diabetes mellitus are seen in epithelium of a distal portion of proximal convoluted tubule and descending longitudinally in the hepatocyte, in the beta cells of pancreatic islets and in the cardiac muscle cells. Okay. So, basically, there is a inherited disease of glycogen, like the person cells can't use the glycogen. Okay. So therefore, the glycogen remains in the cell. Glycogen deposits in the diabetes glycogen deposits in diabetes mellitus are seen in the epithelium of a distal portion of the proximal convoluted tubule and descending longitudinally in the hepatocyte and in the beta cells of the pancreatic islets and in cardiac muscle cells. Necrosis. So, necrosis is defined as a localized area of death of tissue followed by degradation of tissue by hydrolytic enzymes liberated from dead cells. It is invariably accompanied by inflammatory reactions. Cause of necrosis: hypoxia, chemical and physical agents, microbial agents, immunological injury, etc. Two essential changes characterize irreversible cell injury in necrosis of all types. Cell digestion by lytic enzymes. Morphologically, this change is identified as a homogeneous and intensely eosinophilic cytoplasm. Occasionally, it may show cytoplasmic vacuolation or dystrophic calcification. So denaturation of proteins. This process is morphologically seen as a characteristics nuclear change in necrotic cell. These nuclear changes may include condensation of nuclear chromatin, pycnosis, which may either undergo dissolution, karyolysis, or fragmentation into many granular clumps called the karyorexis. Okay, so there are three types of nuclear changes: pycnosis, karyolysis, and karyorexis. Karyolysis, which reflects loss of DNA by the action of a endonuclease, in which case the basophilia very dark purple appearance of chromatin fades. Okay. Pycnosis, which reflects nuclear shrinkage and increased basophilia. In this scenario, the chromatin condenses into solid shrunken chromatin mass. And karyorexis, which reflects a scenario where a pycnotic cell undergoes fragmentation into several clumped chromatin strands, after which it disappears. Okay. Okay. In pyrolysis, the basophilia it decreases because the DNA is damaged, and the DNA is basically the thing that gives the cell a basic property. So if the DNA is not there, so the basic property will not be there, and there will be a loss in basophilia. And in the pyknosis, what time that that the nucleus shrinks. Okay, so so that's why the chromatin it condenses, and the basophilia it is there. Choriorexius, okay. So, fragmentation of the nucleus into several clumped chromatin strands, after which it disappears. Okay. See. Usually, there are four factors required for maintaining the selective ion permeability of the cell: considerable amounts of ATP, structural integrity of a phospholipid bilayer or cell membrane, intact ion channel proteins, and normal association of the membrane with the cytosolic elements. Okay, in any of these factors, if any of these factors are damaged or interrupted, then the cell isn't able to maintain the normal ionic concentration within and outside the cell. This is a point of no return for the cell when it is no longer able to regulate internal ionic concentration. Special mention must be given to the role of calcium in the cell death. Usually, calcium concentration inside the cell are 10,000 times lower than. Oh, okay. So, calcium is more in the outside the cell. Outside the cell, the calcium is more, and inside is less. Okay. Furthermore, several processes within the cell are regulated by very minute changes in the calcium concentration. Thus, once a large influx of calcium occurs, all cell viability is lost, and the cell is far beyond point of no return. Cytotoxicity of oxygen free radicals. So, free radicals are formed in physiologic and as well as the pathologic processes. Oxygen radicals are unstable and are destroyed spontaneously. The rate of spontaneous destruction is determined by catalytic action of certain enzymes such as superoxide dismutase SOD catalase and glutathione peroxidase. If not degraded, then free radicals are highly destructive to the cell since they have electron-free residue and thus bind to all molecules of the cell. This is termed oxidative stress. Out of various free radicals, hydroxyl radical is the most reactive species. Free radicals may produce membrane damage by following mechanisms. First, lipid peroxidation. Unsaturated fatty acid PUFA of membrane are attacked repeatedly and severely by oxygen-derived free radicals to yield highly destructive radicals. This reaction is termed lipid peroxidation. The lipid peroxides are decomposed by transition metals such as iron. Lipid peroxidation is propagated to other sites, causing membrane damage and destruction of organs. Oxidation of proteins. So, oxygen derived free radicals cause cell injury by oxidation of protein macromolecules of cell cross linkages of labile amino acids as well as by fragmentation of polypeptide directly. Accumulation of a free radical can lead to DNA damage. Free radicals cause breaks in single strands of nuclear and mitochondrial DNA. This results in cell injury. It may also cause malignant transformation of cells. Cytoskeletal damage. Reactive oxygen species are also known to interact with cytoskeletal elements and interfere in mitochondrial aerobic phosphorylation and thus cause ATP depletion. Antioxidants. Antioxidants are endogenous or exogenous substances which inactivate the free radicals. These substances include the following: vitamin E, A, and C, ascorbic acid, sulfhydryl compound containing compound enamel, cysteine, and glutathione, serum protein enamel, ceruloplasmin, and transferrin. So types of necrosis. Morphologically, there are five types of necrosis: coagulative, liquefactive, cases, fat, fibrinal necrosis. Coagulative necrosis. This is the most common type of necrosis caused by irreversible focal injury, mostly from sudden cessation of blood flow, ischemia, and less often from bacterial and chemical agents. Okay. So, ischemia is a primary cause of coagulative necrosis. Okay. The organs commonly affected are heart, kidney, and spleen. Heart, kidney, heart, kidney, spleen. Heart, kidney, spleen. Okay. Liquefaction or okay necrosis. Liquefaction necrosis occurs commonly due to ischemic injury and bacterial or fungal infections. It occurs due to degradation of tissue by the action of powerful hydrolytic enzymes. The common examples are infarct, brain, and abscess cavity. For the this coagulative, the cause is ischemia, and for the liquefaction, the cause is the um, abscess formation, abscess cavity. Okay. Cases necrosis is found in the center of foci of tuberculosis infections. It combines features of both coagulative and liquefaction necrosis. Fat necrosis. Fat necrosis is a special form of a cell death occurring at two anatomically different locations but morphologically similar lesions. These are following: acute pancreatic necrosis and traumatic fat necrosis, commonly in breasts. Okay, in pancreas and in breast we see the fat necrosis. In the case of pancreas, there is a liberation of pancreatic lipases from injured or inflamed tissue that results in necrosis of pancreas as well as of the fat deposits throughout the peritoneal cavity, and sometimes even affecting the extra abdominal adipose tissue. Fibrinal necrosis is characterized by deposition of fibrin-like material which has staining properties of fibrin. It is encountered in various examples of immunologic tissue injury, example in immune complex vasculitis, autoimmune diseases, arterial hypertension, and peptic ulcer, etc. Microscopically, fibrinoid necrosis is identified by brightly eosinophilic hyaline like deposition in the vessel wall. Necrotic focus is surrounded by nuclear debris of neutrophils, leukocytoclasis. Local hemorrhage may occur due to the absence of blood vessels. Gangrenous necrosis. So, the type of necrosis is usually due to ischemia, example in gangrene of the bowel, gangrene of limb. On other hand, gangrenous or necrotizing inflammation is characterized by primarily inflammation provoked by virulent bacteria, resulting in massive tissue necrosis. There are two main forms of gangrene: dry and wet, and a variant form of wet gangrene called as gas gangrene. Okay. In all types of gangrene, necrosis undergoes liquefaction by the action of putrefactive bacteria. Dry gangrene. This form of gangrene begins in the distal part of limb due to ischemia. The typical example is the dry gangrene in the toes and feet of an old patient due to arteriosclerosis. Other causes of dry gangrene foot include thromboangiitis obliterans, Buerger's disease, Raynaud's disease, trauma, ergot poisoning. Okay. A line of separation is found at this point between the gangrenous part and the viable part. Morphological features. Grossly, the affected part is dry, shrunken, and dark black. It is black due to liberation of hemoglobin from hemolysis RBCs, which is acted upon by hydrogen disulfide H2S produced by bacteria by information of black iron sulfide. Wet gangrene. So wet gangrene occurs in naturally moist tissues and organs like mouth, bowel, lung, cervix, vulva, etc. Diabetic foot is another example of wet gangrene due to high glucose level content in necrosed tissue, which favors the growth of bacteria. Wet gangrene usually develops rapidly due to blockage of venous and less commonly arterial blood flow from thrombosis or embolism. The affected part is stuffed with blood, which favors the rapid growth of putrefactive bacteria. The toxic products found by bacteria are absorbed, causing profound systemic manifestation of septicemia and finally death. So types of necrosis, liquefaction we see in the brain and cases in case of tuberculosis and fat in case of breast and pancreas, coagulative in case of kidney, liver or heart muscle, and gangrene in case of appendage. So difference between dry and wet gangrene. So dry gangrene it only affects the lower limbs. Wet gangrene on the other hand it affects common in bowel. Mechanism is arterial occlusion in case of dry gangrene and more commonly venous occlusion, less often arterial occlusion, wet gangrene. So macroscopy organ is dry, shrunken and black, moist, soft, swollen and dark. Line of demarcation present between gangrenous and healthy part. No line of demarcation. Hmm. So, presence of bacteria failed to survive and numerous bacteria is present. Prognosis generally better due to little septicemia and generally poor due to profound toxemia. Cases necrosis is the feature of tuberculosis, and fat necrosis is the feature of a pancreas and breast. Pancreas and breast. I will be back in 2 minutes. Just wait for me. I will be back in 2 minutes. Don't go anywhere else. Okay. Yes, guys. So I'm back with and let's begin. So evapotiosis plays a crucial role in maintaining a balance between cell death and division. Error in evapotiosis results in uncontrolled multiplication of cells, leading to different. The unwanted cell removed during process. Cell death, which includes a genetically programmed process of cell suicide in response to particular signals, is called programmed cell death. Genetically programmed process. Okay. Apoptosis, usually programmed cell death, controlled by a variety of extracellular and intracellular signals, which are directed by the environment of the cell and the intracellular signals. Apoptosis is a form of coordinated and internally programmed cell death, having significance in a variety of physiologic and pathologic conditions. Apoptosis is a Greek word meaning falling off or dropping off. When the cell is not needed, pathway of cell death is actually cell suicide. Apoptosis is highly selective process that eliminates injured and aged cells. Causes of apoptosis. Different endogenous tissue specific agent and exogenous cell damaging agents initiate the programmed cell death in particular cell type under critical physiological conditions. Okay. Exogenous activation of programmed cell death include physical agents and infectious agents that act on most types of cells. Physical agents include radiation, physical trauma, and chemotherapeutic drugs, while infectious agents include viruses and bacterial toxins. Further, internal imbalances like growth factor withdrawal, treatment with glucocorticoid, and loss of matrix attachment can trigger apoptosis. Apoptosis in biology processes. Apoptosis is responsible for mediating cell death in a wide variety of physiologic and pathologic processes as under physiologic processes organize destruction during development of embryo during embryogenesis in the development of number of organs such as heart, which begins as a pulsating tube and gradually modified to become a four-chambered pump. Apo- Apoptotic cell death allows for the next stage of organ development, physiologic involution of cells in hormone-dependent tissues, example endometrial shedding, regression of lactating breast after withdrawal of breastfeeding, and involution of thymus in early age. Apoptosis is linked to many pathologic processes and diseases. For example, interference with apoptosis is known to be a mechanism that contributes to carcinogenesis. Cell death in tumors exposed to chemotherapeutic agents, cell death by cytotoxic T cells in immune mechanisms like graft versus host disease and and rejection reactions. Pathologic atrophy of organs and tissues on withdrawal of stimuli, example atrophy of kidney or salivary gland on obstruction of ureter or ducts, respectively. So I would say, the activation of cellular enzymes. One second, please.
अच्छा क्लिनिकल स्किल्स सर क्या पूछा?
कुछ नहीं बोला कि इंटरेक्ट करो डॉक्टर पेशेंट वही वापस.
फिर डॉक्टर पेशेंट
हाँ.
मतलब क्या डॉक्टर पेशेंट?
मतलब पेशेंट को कुछ तकलीफ होगी, मतलब हेडेक, स्टमक एक, चेस्ट पेन, हैंड पेन, हार्ट पेन, डॉक्टर उसको बोलेगा, ही विल इंट्रोड्यूस हिमसेल्फ, ही विल क्वेश्चन पूछेगा. हाँ, क्वेश्चन पूछेगा कि क्या हो रहा है, कैसे हो रहा है, क्वालिटी क्या है, क्वांटिटी क्या है.
सेम फिजिकल
हाँ
डायग्नोसिस.
हाँ. So apoptosis involves the activation of cellular enzymes with apoptosis, however, group of proteases which are particularly active in destroying the proteins of nuclear membranes and cell and can in turn activate DNases which degrade nuclear DNA. These so-called caspases are found in normal cells, but apoptosis is only initiated when these become catalytically active. There are three major phases of apoptosis: initiation or induction, execution, and phagocytosis. The two major types of apoptosis pathways are intrinsic pathways, where a cell receives a signal to destroy itself from one of its own genes or proteins due to due to detection of DNA damage, and extrinsic pathway, where a cell receives a signal to start apoptosis from other cells in the organism. uh, Extrinsic pathway of apoptosis begins outside a cell when conditions in the extracellular environment determine that the cell must die. Okay. Intrinsic pathway of apoptosis pathway begins when an injury occurs within the cell, and the resulting stress activates the apoptotic pathway. In both the intrinsic and extrinsic pathway of apoptosis, signaling results in the activation of family of cysteine proteases named caspases that act in a proteolytic cascade. Each pathway requires specific triggering signals to begin an energy-dependent cascade of molecular events. Each pathway activates its own initiator caspases 8, 9, 10, which in turn will activate the executioner caspase 3. Activation and function of caspases. The mitochondrial and death receptor pathway lead to the activation of Initiated caspase 9 and 8 respectively. Like mitochondrial damage causes the activation of caspase 9 and death receptor pathway. It causes the activation of caspase is called caspase 8. Okay. These activated caspases cleave numerous targets, culminating in activation of nucleases that degrade DNA and nuclear proteins. Caspases also degrade components of cellular matrix and cytosol, le- leading to fragmentation of cellular. Mitochondrial intrinsic pathway of apoptosis. Under stress in cells, activate protein P53, which activate two pro-apoptotic members of the family called Bax and Bach. Bax and Bach. Okay. Bax and Bach inserted into through channels cytochrome C and other mitochondrial proteins escape into the cytosol. Cytochrome Cytochrome C together with some cofactors activates caspase 9. The net result is the activation of caspase cascade, caspase 9, and caspase 3, which activate nucleases, ultimately leading to nuclear fragmentation. Okay. So, so there's the one second. I'll be back. So, so yeah, first step in the intrinsic apoptotic pathway is the DNA damage. So whenever there is a DNA damage, the synthesis of P53 protein is increased, and this P53 protein activate back and back genes to produce the proteins called as Bax and back, and this causes the cytochrome C release from the mitochondria, and cytochrome C forms a apoptosome, and this causes the activation of caspases and especially the caspase 9, and yeah, and then caspase 9 it activates the caspase 3, 6 or 7, and this causes the apoptosis. The death receptor extrinsic pathway of apoptosis. Many cell express surface molecules called death receptors that trigger apoptosis. Most of these are members of tumor necrosis factor TNF receptor family, which contain in the cytoplasmic regions the conserved death domain, so named because it mediates interaction with other proteins involved in the cell death. The death receptors are the type 1 TNF receptors and fast CD95. Fast molecules are cross-linked by fast cell ligand uh, and bind adapter proteins via the death domain. These in turn recruit and activate caspase 8. Caspase 8 activates caspase 3, which causes activation of nucleases and breakdown of a DNA cell death. Caspase 8 activates a apoptotic membrane of BCL2 family called build, thus feeding into the mitochondrial pathway. The common activation of both pathways deliver a little blood to cell. Hmm. Caspase 9 in case of in case of intrinsic pathway and caspase 8 in case of extrinsic pathway. So, morphological features of apoptosis. The the characteristic morphologic changes in apoptosis seen in histology and electron microscopic examination are as under the apoptotic cells are round to oval sunken masses. Then the nuclear chromatin is condensed or fragmented pycnosis or karyorexis. There may be formation of a membrane bound near spherical bodies on or around cell called pro called apoptotic bodies containing compacted organelles. Characteristics unlike necrosis, there is no acute inflammatory reaction around apoptosis and phagocytosis of so phagocytosis of apoptotic bodies by macrophage. Hmm. So there's a difference between necrosis and apoptosis. So Uh, in necrosis, there is cellular swelling. Many cells are affected, and in the case of apoptosis, there is a cellular shrinkage, and one cell is affected, and uptake cell contents ingested by macrophages, and significant inflammation, and cell content ingested by neighboring cells. No inflammatory response, and loss of membrane integrity, membrane bleeding, but integrity maintained, and cell lysis occurs, and apoptotic bodies formed. Okay. Organelle swelling, and lysosomal leakage, and mitochondrial. Okay, guys. So that was it for the reversible and irreversible cell injury, and the apoptosis and the necrosis. So thank you. And bye.